This is Andromeda, our nearest galactic neighbor, a sprawling spiral galaxy that stretches across over 150,000 light-years. It's visible to the naked eye as a faint, ethereal smudge in the night sky. And yet behind that blur lies a world far more complex than we could ever imagine. Each tiny point of light we see in the Hubble image is a giant star, many larger than our Sun, and likely each with its own system of planets, comets, asteroids, and celestial debris. Each star tells its own story, a story that has unfolded across millions, sometimes billions, of years. The Hubble Space Telescope has now given us the most detailed portrait of Andromeda ever captured. The clarity is staggering. By the time your eye reaches the galaxy's densely packed nucleus, the stars form a solid, golden glow, almost like molten light suspended in space. Andromeda is not just a calm, graceful spiral in the night sky. It is a place of complexity, of structure, and of hidden histories. Observing Andromeda allows us to glimpse the violence and interactions that have shaped its collisions with other galaxies, streams of stripped stars, and bursts of star formation triggered by gravitational encounters. Andromeda's past is written in its structure, its rings, its spiral arms, and its halo. By studying it, astronomers can understand galaxy evolution in a way that would be impossible from within our own Milky Way. Our fascination with Andromeda goes back over 1,000 years. In 964 AD, Persian astronomer Abd al-Rahman al-Sufi recorded it as a faint, nebulous smear in the sky. In 1612, Simon Marius became the first to observe it through a telescope, revealing early hints of structure. By 1764, Charles Messier catalogued it as M31, and mid-19th century observations by William Parsons, using the 72-inch Leviathan telescope, uncovered the first spiral structure in a nebula. In 1888, Isaac Roberts captured the first photographic image of Andromeda, clearly showing its spiral form. Yet astronomers still debated whether it was part of the Milky Way or a separate island universe. By the late 19th century, differences in motion confirmed these spiral nebulae might indeed be galaxies of their own. The answer finally arrived in 1925 through the work of Edwin Hubble. Hubble focused on Cepheid variable stars, stars whose brightness fluctuates in predictable cycles. These stars are known as standard candles because their intrinsic brightness allows astronomers to calculate distance with precision. Hubble measured the light curves of two Cepheids in Andromeda. The results were astonishing. The stars were approximately 1 million light-years away, far beyond the estimated boundary of the Milky Way, which at the time was thought to span no more than 300,000 light-years. This single discovery confirmed that Andromeda was not part of our galaxy, but an entirely separate galaxy in its own right. Humanity's cosmic perspective expanded dramatically overnight. Our Milky Way was no longer the universe, it was merely one of countless galaxies scattered across an incomprehensible void. This was not just a scientific milestone, it was a conceptual leap. Andromeda went from being a faint nebula to a massive island universe, filled with stars, planets, and cosmic events. The universe itself became immeasurably larger, and the very idea of our place within it shifted. With this revelation, Andromeda became a central reference point in astronomy. By studying its structure, composition, and interactions, scientists began to understand galactic evolution, the life cycle of stars, and even the potential for future collisions between galaxies. Andromeda's story was no longer abstract. It was something we could observe, measure, and learn from. Fast forward to January 16, 2025. After a decade of meticulous observation, the Hubble Space Telescope unveiled the most comprehensive image of Andromeda ever captured. This wasn't just a single snapshot, it was the culmination of over 1,000 Hubble orbits, stitched together into a photomosaic spanning 2.5 billion pixels. Over 600 individual exposures were combined, creating a portrait so detailed that astronomers could now resolve 200 million stars, the largest census of any galaxy in history. The scale of the image is staggering. Andromeda is shown nearly edge-on, tilted 77 degrees relative to our line of sight from Earth. The northern region appears to the right, while the southern stretches to the left. Despite predictions that Andromeda could host as many as 1 trillion stars, Hubble captured only the brightest, most resolvable stars. Yet even this fraction is enough to provide a breathtakingly detailed view of the galaxy's structure, star-forming regions, and past interactions. This unprecedented level of detail allows scientists to reconstruct Andromeda's history. With each resolved star, astronomers can study stellar populations, metallicity, age, and distribution, gaining insights into the events that shaped this galactic neighbor. For the first time, humanity can explore Andromeda not as a fuzzy blur or an abstract nebula, but as a living, evolving galaxy, its past etched into every spiral arm, ring, and halo. Andromeda is classified as a spiral galaxy, stretching roughly 150,000 light-years across, with spiral arms that radiate outward from a dense, luminous nucleus. While the spiral form is familiar, Andromeda has unique features that set it apart from most galaxies we study, including our own. The PHAT program, Panchromatic Hubble Andromeda Treasury, completed in 2015, provided a high-resolution view of 1/3 of Andromeda's star-forming disk. Images were captured across 6 spectral bands, from near-ultraviolet to near-infrared, allowing astronomers to identify young, blue, metal-rich stars in the galaxy. One prominent feature is an elliptical ring of star formation, roughly 10 kiloparsecs from the nucleus. These newborn stars are hotter, brighter, and contain heavier elements than surrounding stars, indicating they formed from enriched material. Zooming in reveals stars that appear like grains of sand on a beach, a comparison the Hubble team used to describe the sheer resolution and density of data. Further studies, including observations by Spitzer's infrared array camera in 2006, revealed a second, inner dust ring hidden near Andromeda's center. Initially mistaken for a mini-spiral, this ring, along with the outer one, pointed to a more violent past than previously assumed. These 2 concentric rings are not anomalies, they are cosmic fingerprints, evidence of a collision between Andromeda and a companion galaxy roughly 210 million years ago. Astronomers realized that the rings of Andromeda are like ripples in a pond, caused by a catastrophic impact. This first collision involved the dwarf galaxy Messier 32, located just 5 kiloparsecs from Andromeda's center today. Numerical simulations of the collision showed that a head-on encounter could create the rings we see in both the outer and inner regions of the galaxy. Even gaps in the outer ring, where it intersected with Andromeda's spiral arms, were reproduced in these models. But Andromeda's story doesn't end there. High-resolution imaging revealed a more complex past, including evidence for an even larger collision. The culprit was likely an ancient version of M32, dubbed M32P. This galaxy, with a mass equivalent to 25 billion suns, merged with Andromeda between 5 and 2 billion years ago. Its gas was captured by Andromeda's gravity, triggering a burst of star formation that produced roughly 1/5 of Andromeda's current stars. This explains Andromeda's population of intermediate-age stars, which had puzzled astronomers for decades. These stars form a second wind in star formation, distinct from older bulge stars and younger disk stars. Hubble's detailed imaging even allows scientists to identify the stripped core of M32P, surviving today as M32, complete with a central black hole between 1.8 and 5 million solar masses. Andromeda's galactic halo contains 36 dwarf galaxies, each a potential participant in past interactions. With Hubble's resolution, astronomers can now begin to trace small-scale collisions with these satellites, uncovering scars from past encounters that are otherwise invisible. Every ring, stream, and stellar population contributes to a story millions of years in the making, a narrative of creation, destruction, and rebirth written in starlight. As we shift our gaze from Andromeda's tumultuous past, we naturally wonder about its future. This colossal galaxy is not just drifting silently through space, it is the largest gravitationally bound member of the local group, paired only with our own Milky Way. These 2 giants are engaged in a slow, inexorable dance, drawn together by gravity over millions of years. Estimates from 2012 suggested that Andromeda is moving toward the Milky Way at roughly 110 kilometers per second, potentially leading to a galactic merger in about 4 billion years. From a human perspective, that is unimaginably distant, far beyond the lifespan of our species. or even the Earth itself. Yet, for astronomers, it is a tantalizing glimpse into the cosmic ballet that shapes our universe. New observations from the 2025 Hubble image have refined this picture. By precisely measuring 55 Cepheid variable stars in Andromeda and combining the data with the orbits of other local group members, including the Large Magellanic Cloud, researchers have concluded that a merger is no longer certain. There is roughly a 50% chance that Andromeda and the Milky Way will collide within the next 10 billion years. Our galaxies might continue to coexist, gracefully avoiding collision, or eventually merge into a spectacular new structure, sometimes called Milkomeda. While Hubble provides breathtaking snapshots, the story of Andromeda is far from complete. Programs like PHAT and PHAC have mapped hundreds of millions of stars, uncovering hidden structures and disturbed regions that bear the scars of past collisions. In June 2025, the Chandra X-ray Observatory captured the galaxy's supermassive black hole in unprecedented detail. Each new observation reveals more about Andromeda's internal dynamics, its history of mergers, and the processes shaping its ongoing evolution. These discoveries underscore a fundamental truth. The universe is not static. Galaxies evolve, collide, and transform over billions of years. Andromeda serves as both a laboratory and a mirror, reflecting the mechanics of galaxies and the potential future of our Milky Way. Its intricate spiral arms, ancient collisions, and hundreds of millions of resolved stars reveal forces that shape galaxies across cosmic time, allowing us to glimpse patterns otherwise invisible from within our own galaxy. Just 2.5 million light-years away, Andromeda may seem distant, yet it is intimately connected to our galaxy, and perhaps even to our far future destiny. As Hubble, Chandra, and future telescopes continue probing its depths, Andromeda will keep revealing secrets. Whether or not it collides with the Milky Way, studying this grand neighbor brings us closer to understanding our place in the cosmos. We are observers in a universe full of stories waiting to be told, and Andromeda remains one of its most remarkable narrators.